The remainder theorem is a quick way to divide a polynomial by a linear factor, which we will call x minus k, and obtain its remainder. By a linear factor, we really mean anything that can be represented by the line y equals x minus k. An example of this would be x minus 4, which could be represented as the line y equals x minus 4. So let's see what we really mean by this. A more broad definition of the remainder theorem would be that given a polynomial, which you will call p of x, its remainder, r, when divided by x minus k, the linear factor, is p of k. The reason we say p of k is because we want to substitute in a value that makes the linear factor x minus k equal to 0. For instance, when we plug in 1 into the linear factor x minus 1, this expression would be 0. Likewise, when we plug in negative 1 into the linear factor x plus 1, we would get 0. Now, this means that if the remainder equals 0, which is our ultimate goal here, x minus k is a factor of p of x. This simply means that we can factor out this expression from this polynomial without any problems. Let's apply the remainder theorem. In our example, we are asked to find the remainder r in the expression x cubed minus 4x squared plus 3x minus 8 divided by x minus 3. Now, recall that the numerator is simply the polynomial, which we call p of x, and that the denominator is the linear term, which we called x minus k. Also remember that our goal is to substitute in k, which makes this value 0. So let's do that. 3 quantity cubed minus 4 times 3 quantity squared is 3 times 3 minus 8. Notice how we substitute in 3. 3 would make this expression equal to 0, so that's why we apply it here. So let's go ahead and evaluate this. 27 minus 4 times 9, that would be 36, plus 9, minus 8. This would be negative 9 plus 9 minus 8, and this is simply 0 minus 8, which is negative 8. In this example, our remainder, which we call r, is negative 8. In this example, our remainder is equal to negative 8 and not 0. This means that the linear factor x minus 3 does not factor out of this polynomial perfectly, as we have this remainder. So let's say for the second example is any different. We want to find the remainder r in this polynomial divided by this linear factor. So as we can recall, we want to substitute in whatever makes this expression equal 0. In this case, it would be negative 2. So let's do that. Negative 2 quantity cubed plus 2 times negative 2 quantity squared plus 4 times negative 2 plus 8. So this simplifies to negative 8, this simplifies to 8, this simplifies to negative 8, and this to plus 8. And as we know, this is 0, and this is 0 for a combined total of 0, which is our remainder. As it is 0, the linear term x plus 2 factors perfectly out of the polynomial x cubed plus 2x squared plus 4x plus 8. And if we quickly factor this, we can actually verify that it factors out perfectly. Here we have a bonus question in which we're asked to find the value of k so that x minus 1 is a factor of the expression k squared x cubed minus 4kx plus 4. If x minus 1, which is a linear term, happens to factor perfectly out of this expression, it would mean that the remainder equals 0 when we substitute in 1, which also makes this equal to 0. So let's go ahead and do that. This would mean it is times 1, and in here it would also be times 1, which is why we substituted in 1 for x. So if we simplify this, we get k squared minus 4k plus 4 equals 0, and now we have a factorable quadratic. This simplifies to k minus 2 quantity squared equals 0, a perfect square, meaning that k equals 2. As we have established that k equals 2, we can go ahead and substitute it into the original expression. 2 squared equals 4, minus this, minus 4 times 2 would be 8x, plus 4. And since we know this linear term x minus 1 is a factor of it, it means that when we substitute it, we would substitute in 1, this entire expression should be equal to 0. So minus 8 times 1 plus 4 equals 0. And then 4 minus 8 plus 4, negative 4 plus 4 indeed equals 0, meaning that x minus 1 is a factor of this polynomial.